My name is Michal Hrušecký, and in CZNIC, I'm responsible for the Turris project. And earlier today, we had here a big unveil of our new Turris router. But because we have a huge international community, I wanted to do the similar talk with even in English. And it wouldn't be just the unveil of the new router, but I will also speak about other parts of the project, and then Mike will join me and talk more about the security research program that we do as part of the Turris project. And that's why we actually came into being. So let's get to the most interesting part for those who weren't at the previous talk, and that's showing you the new router. By the way, if you are interested, they are already on our booth. So you can go there and ask more questions. And we also have one in the gaming area. So this is how it looks like. That's the box. When I open it up, you can see there are 4 antennas. There is place for 4 more. One of the options that we were thinking about when we were designing the router was that we might want to add a 5G version later on, and 5G adds another 4 antennas. So this is the router. It's black and white. It still has some RGB LEDs. Now, one of the new things is that it has a display and D-pad. We have spare holes in the case. Those are there because you might want to mount it into your rack. So those are ready for the rack mount. We have several ports in the back. We will talk about them later on. And yeah, let's power it up. We have a power source. It's a pretty big one. Actually, it's more than enough to power our routers. The power source that we are shipping is 90 watts, but the typical power consumption is nowhere near that. One of the features that we have is that our routers are pretty extensible, so you can add more peripherals to them, and those peripherals can be quite power hungry. So yeah, I already showed you SFP cages, and in those SFP cages, you can add 10 gigabit copper modules, and those can easily take even 5 watts each. One thing that I already spoke a little bit about is the possibility to add 5G, and 5G can also consume quite some energy. And as with previous models, we also have a USB 3 that you can use to extend your device with something like rotating hard drives. So all these power consumptions stack up, and we wanted to ship with a power source that is powerful enough to power anything that you will think about. So this is a test application to test whether everything works well on the display and that there are no dead pixels, and to make sure that the D-pad can function in every direction. But that's not the main use of the display, hopefully. But yeah, this is something that you can play on our booth. And as I was mentioning, retro gaming area, we also have one device that can play Doom. But let's show you something more useful, because yeah, I have here a device that somebody left in some weird state, and I don't know what went wrong, or write in this case. But I want to do something else, so I will start up a rescue mode. If you remember our previous router, Turris Omnia, it had a rescue mode where you could roll back to the previous snapshot and stuff like that. And you had to count LEDs. And based on that, it did different actions. Now with display, we can provide you with a menu where you can select what you want to do. And yeah, let's go to the last snapshot. And hopefully, we will end up with something different on the display. While it is booting, we still have RGB LEDs, as you can see. Those can be also set up in different way, but because we have a display, we have less of them. You can see that now it turned from green to yellow. That means that kernel started and now the system is booting up. It takes quite some time because most of the time is taken by Wi-Fi drivers loading the firmware and starting the Wi-Fi's, which yeah, it's not that visible on the device without antennas because I was too lazy to screw them in. If you want to see how I'm unable to screw on antennas, take a look at the recording of the previous session. So this is the default view that you have on the router when it's booted up. You have there network traffic going to the internet. You have there LAN IP address and WAN IP address. I'm not connected to internet, so there is no traffic. And my IP address is kind of boring. But you can see down here some notifications with some categories, and you can browse through the notifications and take a look what's been going on your router. Those are, for example, if update happened or if some error occurred and stuff like that. And one of the interesting features is that if somebody comes to visit you, you can display QR code to connect to the Wi-Fi. This is the guest Wi-Fi. And yeah, without opening the web user interface, without fiddling on your notebook or your phone, you can easily share access information to the guest network that is isolated from the main network. So no access to the user interface. You have access only to the internet, and you can also limit the speed. So that was the live demo. If you want to see more, come to our booth. And now let's talk about the rest of the features that are there. As I said, we have various ports available. We have two USB 3s. One is on the back and one is on the front. We have two SFP Plus cages that are able of doing 10 gigs. And actually, we tried and make sure that we can net 10 gigs. So you would use, you will be able to use 10 gigabit uplink in your local network. If you don't have a DAC cable or fiber in your computer, you can use Ethernet ports that are still available there. There are 4 Ethernet ports. Each of them is 2.5 gig. So it adds up to 10 gig again. Some comparison to the previous flagship that we had, Turris Omnia. It used to be 32-bit ARM. Now we switched to 64-bit. We are now quad-core and running at higher speeds. As I said, yeah, there is 2 SFP Plus 10 gigabits and 4 RJ45s. All of them are connected directly to the CPU, so don't worry about us mentioning as a one 10 gigabit port. If you have just slow internet, you can use classic Ethernet. And actually, during the first setup, the router will detect whether there is a link on one of the Ethernet ports, ETH0. And if there is a link on that port, it will use that one as a one. If there is no link on that one, it will use SFP. And during the first run wizard, you will be able to choose on which port you have the internet and on which port is the LAN network. Apart from that, one thing that the display is really good for is the first setup, because during the first boot, the router will generate a random password for Wi-Fi, and it will display on the display credentials, so you are able to connect to the Wi-Fi in a secure way, even on the first boot, and you are able to go to the first run wizard even over the Wi-Fi. Speaking of Wi-Fi, in the previous model, we had the Wi-Fi 6, and we had 2.4 gigahertz, and we had 5 gigahertz. In this device, we actually have 3 bands that runs simultaneously. We have 2.4 gigahertz. That's the band that is most commonly used, and you get most interference there. For this band, we are using Wi-Fi 6. And for 5 gigahertz and 6 gigahertz, we are using Wi-Fi 7. We still have same size eMMC, 8 gigabytes. But if you want to use something else and run some containers and stuff like that, there is an option to put NVMe inside, so you can extend your storage. And if you are running some different system later on, you might just want to forget about eMMC altogether, and from U-boot, you are able to boot directly using NVMe. As I was saying in the beginning, we are ready for 5G variant. So there are a few more holes available for the extra antennas, and there is a slot inside that you can put your 5G modem in. And although we boosted the performance quite a bit, we are still completely passively cooled. This is how it looks like inside. You can see that we have 3 M.2 slots with different keys. One is for NVMe, another one is for that 5G modem, and the third one is occupied by Wi-Fi. As you can see, there are 2 Wi-Fis. One is in M2 slot and can be replaced for a new one. But this is actually the first model that we have that has also one onboard Wi-Fi. We decided to put one of the Wi-Fis on board because it made sense from technological point of view, and I'll be honest, it wasn't that expensive. But the other part is that we haven't found any tri-band Wi-Fi card that we could put in the slot. So we had to cover it with multiple, we wanted to cover all 3 bands, so we had to cover it with 2 Wi-Fi cards, and we use it like this. You can see there are still 4 duplexers. Those are mixing the signal from 2.4 gigahertz card that is on board and 5 and 6 gigahertz card that is in the slot. Thanks to that, we are able to stay with 4 antennas in the Wi-Fi version, and we have still room for another 4 antennas for 5G version. Available soon. Basically, we finished everything. It's up and running. We have it in stock, and we are just finishing various paperwork to be able to actually sell it. So you can take a look at our booth, play with the device. We are also accepting some pre-orders there. And if you want to know exact date when it will be generally available, you can join our newsletter and we will let you know once we finish all the paperwork so we can actually sell it. That was the Turris Omnia NG part. Now, I wanted to also talk about Turris OS and its evolution. I always do it here. Turris OS 9 is coming, and it's already actually available on these Omnia NGs. Those don't have support for, we don't have support for Omnia NG in anything older. We hope to be able to release RC before the conference. Unfortunately, we got a little issue there, and we were unable to release the RC yet, but we will release it pretty soon. Currently, we have it in most of the development branches. Only one that is still missing is the RC, and then the final release. What prevented us from releasing it is that somebody during our testing, and well, we do public testing on our forum with our users. Some of our users noticed that LEDs on the Omnia are not blinking correctly with Wi-Fi's. And there was a change in OpenWRT 2410, and Wi-Fi interfaces names changed. So we need to adjust it so we don't break blinking of the LEDs on the Omnia. That's currently the only thing that is stopping us from releasing it. And it was found last week because no one before noticed that LEDs are blinking differently. So we need to fix that. We hope that it will be easy fix. And as soon as we fix that, we will release RC, and then we will release Turris OS 9. Rest of the system is working, and we are pretty confident that migration will be seamless. And now I hand over to Marek, who will be talking about our security research program, Turris Sentinel, and will tell you what our attackers were up to.
So, hello everyone. My name is Marek, and I would like to present some data from the Turris Sentinel project. So, like short introduction about me. I am a human geography student, and I'm part of a urban structure research team. And in CZNIC, I work in Turris team. Previously, I worked as a tech support specialist, and now I work as a data analyst for Turris Sentinel. So let's go through a short Turris Sentinel intro. So Turris Sentinel, or like Turris project in general, started as a security research program, and it started as a project for gathering information about attacks on the internet and about attackers. And the information we gather, we use to also protect our devices against these threats. Nowadays, this project is opt-in. So if you own a Turris device, you have to agree to a license agreement to be part of it and to actually use your device for the gathering of the information and to use the dynamic firewall. Turris Sentinel is composed of minimal honeypots, which are just emulating logging into application layer services. Currently, we are running 4 of these, or we have 4 of these, simulating HTTP, FTP, SMTP, and Telnet. These minimal honeypots are very easy on resources, so they are running locally on the devices. We are also, or at least we would like to enhance this portfolio of minimal honeypots to other application layer services. And we're also running a full-size honeypot, which is simulating SSH. And this honeypot is running on our servers because it's much more demanding on the devices. Yeah. We are also gathering information from firewall logs, and what information we collect. We collect information about IP addresses that are trying to connect, so we can actually localize these IP addresses via ISN. Currently, we are also supporting IPv6. We are gathering ports and protocols, actions, which are login, connect, port scans, and messages. And using these minimal honeypots, we're also gathering credentials that these attackers use, so we can see the most common logins and passwords they are using or try to use to get into the services. And also through the SSH honeypot, we also gather information about commands that attackers are trying to run on the devices. We do not collect any information about outbound traffic. This project only collects information about rejected connections coming to the devices. So, data outputs from Project Sentinel. The main one is a gray list, which is updated in real time from the information we collect. This gray list is used in the dynamic firewall, which is located on Turris devices. And we also publish this gray list in a publicly available nightly list, which is available on the link which is in the presentation. The data is also visualized in our webpage called Sentinel View. You can see real-time visualizations of changing of the gray list and incoming attacks. And there's also a password checker, which is like which is sort of like a have I been bond. Yeah, if you've seen Have I Been Bond, which is a website where you can check your password if it's been hijacked or if it's known. We have some kind of same thing from our data. We also share our data with Czech National CSIRT team for their analysis. So let's look at the data. First, let's look at attackers and incidents. So I took a look at Q2 and Q3 of 2025. So as we can see, over IPv4, we can see almost like 1.6 to 3.1 billion incidents during these quarters. The change between Q2 and Q3 was 86%. So it's more like 1.4 billion incidents more for Q3. And if we take a look at IPv6, we can see that the numbers of incidents are much smaller. This could be because of many reasons. One of the reasons could be that our data is kind of biased because only like a third of our devices are running over IPv6. So it's an important thing to think about. But we can see that there's only 300 to 200,000 incidents happening during quarters. And also between Q2 and Q3, the number of incidents actually got down by 34%. And we can see that only 0.19 per mil of incidents for Q2 were over IPv6, and for Q3 only 0.07 per mil incidents were over IPv6. So we can see that there's a significant difference between attackers using IPv4 and IPv6. So let's look at attackers. These numbers actually show unique IP addresses, which we take as like a single attacker. You can see that over IPv4, there's 1.5 million attackers attacking Turris devices. And overall, we can see that over Q2 and Q3, the numbers of attackers are getting lower, also in over IPv6. But the same thing goes for IPv6. We can see that there's a huge difference between number of attackers over IPv4 and IPv6. If you take a look at the portion, only 0.68 per mil for Q2 and 0.75 per mil of attackers for Q3 were using IPv6. We can see that the trend is that number of attackers is going down, but as we can see, number of incidents is actually going up. This is an average number of incidents per day. You can see that for Q3 we have some around 33 million incidents happening per day. It actually went up by 80% from Q2. And over IPv6, we can see that it's actually getting less popular, at least in this time window. The number of incidents per day actually got down by 35%. So I created some interesting metrics. The first one is average unique attackers per device, which I actually named device popularity. So actually, how many attackers are trying to attack a single device? We can see that the number is around 8,000 or 9,000. Between Q2 and Q3, it actually got down by 6%. And another metric is average incidents per device, which I named device exposure. And we can see that on the average, around 1 million incidents are happening on Turris devices for quarters. And between Q2 and Q3, the number actually got almost doubled. So you can see 95% change. Another metric you could already know because we've already been showing this. We name it attacker promiscuity, which is average devices targeted by single attacker. You can see that attackers roughly attack around 13 Turris devices each. And we can see that it's slightly getting higher. So we can see that there's less attackers, but the attackers that are still active are more active than ever. So we can see the distribution of unique attackers per device. We can see that most of the devices get attacked by kind of like 4,000 attackers or something like that for Q2. And for Q3, we can see it kind of changed. There's more devices getting attacked by a small number of attackers. And the maximum of attackers attacking one device was around 58,000 unique IP addresses or attackers. So this is it's a list of incidents per trap per the minimal honeypots. we can see that SMTP is still the most desired target. We can see almost 107% change over Q2 to Q3. And all of these honeypots are getting more activity. Only Telnet is getting less popular. Maybe it's because it's an older service, but still we can see over 200 million incidents happening there. If we take a look at the attackers per traps, we can see that, as we saw before, the number of attackers is actually going down. The highest change for a minipod was for Telnet. You can see a change of about 30% of attackers, of less attackers. So, but an interesting thing is that even though Telnet is not so desirable, there's it has the most diverse set of attackers of our honeypots. This is a time diagram of incidents happening over time. I'm actually looking at these visualizations, and I'm still looking for the day where I find a connection between a real-world event and the events happening. But unfortunately, I haven't found any real-world event that I could connect to these. We can see that the activity over SMTP is the highest. In Q2, we can see that there was a little bit of increase of activity for Telnet. And as you can see, FTP and HTTP in this kind of scope is almost not visible. So let's take a look at ports. These are tables. I'm sorry, I forgot to actually label them. The table which is on the left is for Q2, and the table which is on the right is for Q3. You can see that the most targeted port is 5353, which is for MDNS. You can also see port 5678 on the second or third line of Q2, and also port 10,001 over UDP. These ports are so 5353 is MDNS, 5678 is for MikroTik neighbor discovery, and the later one, 10,001, is for ubiquity air control. These services actually monitor the network and search for other devices connecting to it. So these numbers are mostly, we think, are mostly biased because people are connecting Omnias into local networks with these kind of services, and the packets of these services actually are stopped by Sentinel and are logged as incidents. We can also see port 51413 and also port 6881. These ports are for transmission and BitTorrent. Overall, these services are very popular for attackers. Other ports we can see is IRC, also HTTPS, which might be our next kind of target for minimal honeypot. We can see that the MDNS protocol or port seen an increase of records over from Q2 to Q3. Also port 6667, which is for IRC, and also the 51413, which is for BitTorrent, or no, not transmission, BitTorrent client. Yeah. So now we're going to see like a Hall of Fame, which is kind of like a Hall of Shame, because we're going to look at top attackers over these quarters. As we can see, most of the top attackers over Q2 were from Ireland. The best attacker was from Netherlands. We can see one attacker from Germany and also 3 attackers from Romania. In Q3, we can see that the attacker from Q2 from Romania got the first position, and we can see an increase in attackers from Ireland and decrease of attackers from Romania. As you can see, the attacker from Germany managed to get a little bit higher in this score. Now we are looking at attackers, like top attackers for each minipod. You can see the Romanian attacker that we already saw on the last slide, which targeted SMTP. The attacker which attacked HTTP the most was from Russia, and attacker attacking Telnet the most from Argentina. And as we can see, FTP was attacked by a French attacker that actually managed to keep his first position over Q2 and Q3. So now we are looking at top ASNs with the biggest number of attackers going from there. Let's note that we do not shame these companies. We actually think that it's a very hard work for them to battle against these attackers using their IP addresses. But as we can see on top place, there's a national internet backbone from India, which actually managed to stay on top for both of these quarters. You can also see 2 of China ASNs, China Net Backbone, China Unicom, and also Cloudflare for Q3. And over IPv6, the top position is maintained by Hurricane Electric from USA, and the second position is maintained by DriftNet from UK. And we can also see Scale-Up Technologies from Germany and DigitalOcean from USA. So let's take a look at the credentials we gathered from these attackers. Here we can see the most used usernames for attackers. As we can see, those are commonly used usernames on devices. You can also see telecom admin, which is a default user for Huawei routers. And I think we can see that like the general idea to reject logging into root account is a good kind of practice, because these well-known users are actually the most tried by attackers. If you take a look at passwords, the top positions are maintained by very simple passwords, also with using lead code or keystrokes. So as you can see, a good rule of thumb is to use a generated password, randomly generated password, not these kind of common passwords. Yeah. So I'd also always take a look at the username and password combinations. So the most used username and password combination for Q2 was root for login and password iCatch99. When I took a look at the internet, this is the default login and username and password for iCatch IP cameras. If you take a look at the data, which is not visible here, the other positions, there's also another IP cameras trying to attackers that are trying to get into them, and we can also see telecom admin from Huawei. And at Q3, we can see these two highlighted usernames and passwords, which look kind of weird. These are most probably by automated scripts that are ignoring the login credentials of our minipods. So on our website, Sentinel View, you can see the global statistics of incidents happening over the globe. The map that you can see on Sentinel View is for absolute data, where you can see the absolute number of incidents coming in from the country. As I study geography, as I already mentioned, this is not a kind of a correct way to approach this analysis. It's better if you're creating a map, it's better to visualize relative numbers. So I created this metric, which I call number of attackers per 1,000 internet users. And as we can see for Q2, the top country with the highest number of attackers per internet users is actually Ireland. We can also see Uruguay. Then we also see Kuwait here, together with Venezuela, and on the topmost places is also India, Iran, Sweden, and Zambia, and also Netherlands as well. If you take a look at Q3, you can see that Uruguay managed to take the first place. Ireland is right behind. And we can also see that Georgia managed to get on the top third place. And yeah. So conclusions. Check your passwords. Stop using common and default passwords. If you know what you're doing, use IPv6 because it's safer. If you wanna, you can buy a Turris device because it's the safest. And if you already have a Turris device, I would like you to actually join Turris Sentinel because I want and would like to have more data to analyze. So I thank you for your attention. Yes, I thank you for your attention, even for Michal. And if you have any questions, don't hesitate to ask them here or actually come to our booth.
Já děkuji za prezentaci. Já budu mluvit česky teda. V angličtině to bylo hlavně kvůli tomu online přenosu a pro záznam, takže pokud máte dotazy, tak se ptejte klidně česky. Tak já jdu běhat.
Používají data ze Sentinel, jsou ty data používané ze Sentinelu v nějaký feedback loopy i k těm providerům internetu těch útočníků? Nebo se používají čistě jenom pro firewall a jakoby čistě jako pro obranu?
I will repeat the question in English.
I can ask in English.
Okay.
That's okay.
Basically, the question was about whether those data are getting back to the ISPs and people that are managing the networks that are source of the attacks. Yes. Well, we are, as we said in the beginning, we are sharing all this data with our CISR team, and those people are in contact with other people around the world. And when there is something interesting and systematic, we are sharing this data. And they are actually in contact with other CSIT teams around the world, and they can go directly to those guys. But what we see quite often in those data, as you saw in ASN analysis, most attacks come from big ISPs or big cloud providers. And when we take a look at some of the top attackers, not the one that stayed there for 2 queues, but sometimes when we see a really active attacker, we see that he's active for a few days. And when we saw a really active attacker that did most of the attacks the whole day, then we saw that he was taken down in a few days. So we know that those networks are really large, and catching those people is hard. But we see that various cloud providers are really working on taking down these attackers. So yeah, we are sharing the data through our CISO team. We have no capacity to inform everybody, but they are doing some automated analysis and sharing the data further.
So now that we know that IPv6 is safer, is there a way for the new Turris and Turris OS to be configured and the setup wizard to be done over IPv6 without typing in the IP address? Maybe some MDNS or some sort of.
Well, for some time we already support the zeroconf, so you can use Turris local. Also, if you want to get access to your router, we also set up FE80:1 IP address on the router, as is common practice for the routers, but that's link local address. Turris local will advertise not this one, but the normal IPv6 address. And since the beginning, Turris routers generate local IPv6 address for the LAN network, so you can use that one to connect. And Turris.local should announce that one as well, or public public IPv6 if you have prefix delegation from your ISP.
Peterka, good afternoon. Is there any mesh support in NG if I would like to use an external AP?
There is some support in OpenWRT itself, but not for the, I think it's not for the common mesh systems that are used by some other providers, but for the mesh, that's, I think, 802.11s, I believe, is mesh or something like that. And yeah, you can set up a mesh network on the Turris routers because it's standard OpenWRT, and OpenWRT systems use the mesh networking for networks like Freifunkt and similar, but it's not available in our reference user interface, and it's not interoperable with common IP systems. At least I believe it is not, unfortunately.
I have a question regarding the new hardware. What was the most challenging thing during the development? Because I have a background information from distributors that it wasn't easy task.
Well, the most challenging was to find the right components to build it on. We tried with different SoC, and it was really hard. But actually, this one is based on Qualcomm, and we wanted to try to develop a router with Qualcomm for a long time. But because we are a small company from Czech Republic and our numbers are not that high, it was really hard to actually get in touch with them and convince them that we are a reliable partner and to actually convince them to do business with us. But in the end, they decided to give it a try, and it was, once we started working with them, it was working really well. And I hope from their side as well. So yeah, the hardest part in our situation, the hardest part is to get big companies to talk to you actually and convince them that it makes sense to do business with you because you are small and from some small country in Europe. So convincing them that it makes sense.
So there is no question. So thank you, Michal, and thank you, Marek, for the presentation. If you will have something to ask, as Marek said, or Michal, visit the booth, which is over there outside the rooms. And once again, thanks a lot, and wish you fortune.
Yeah, thank you for your attention. Bye.